Okay, if we're given a system of nonlinear inequalities, we want to sketch a graph. Number one, we're going to find the intersection points by solving the corresponding system of nonlinear equations. Number two, we're going to graph the nonlinear equations. Number three, we're going to find the shaded regions of each inequality. Number four, we're going to identify the feasible region as the intersection of the shaded regions of each inequality or the set of points common to each inequality. So for example number 5, we're going to graph the given system of inequalities. So inequality 1 is x squared minus y, which is less than or equal to 0. Number 2, we have 2x squared plus y, which is less than or equal to 12. So the first thing we're going to do is find the intersection points by solving the corresponding system of nonlinear equations. So if we're going to solve the system, instead of using the less than or equal to, we're going to use equals and just solve the system. So the two equations are clearly parabolas, and we can find the points of intersection by the elimination process. If we add both equations, and the variable y will be eliminated, and then we can solve for x. So we get 3x squared, which is equal to 12. Divide both sides by 3, we get x squared, which is equal to 4. If we take the square root of both sides, we get x, which is equal to plus or minus 2. And now we're going to substitute the x values into one of the equations and solve for y. So let's take a look at equation number 1. We have x squared minus y equals 0. So we're going to plug in 2 in for x. So 2 squared is 4 minus y, which is equal to 0. Subtract 4 to both sides and divide by a negative. We get y is equal to 4. So when x is equal to 2, which is our x coordinate, we got y to be 4. Now, when x is equal to negative 2, again, we're going to plug it into our first equation. So we plug in negative 2, when we square it, we get 4. 4 minus y is equal to 0, so we're going to subtract 4 to both sides, and then divide both sides by a negative, and now we get y, which is equal to 4. So now the x coordinate is negative 2 with a y coordinate of 4. So the 2 points of intersection are 2, 4, and negative 2, 4. And notice that the equations can be written as follows. So the first inequality, what we can do is we can solve for y by first subtracting x squared to both sides. And then if we divide by the negative, we have to flip the inequality and we get y, which is greater than or equal to x squared. And for number 2, we have 2x squared plus y, which is less than or equal to 12. So we can subtract 2x squared to both sides to get y, which is less than or equal to negative 2x squared plus 12. So if we graph each inequality, we can see that y is greater than or equal to x squared. So here is our parabola for x squared, which is in red. And then the parabola negative 2x squared plus 12 is going downward with a y-intercept at 12. And so where do they intersect? Well, they intersect at these points, and the shading part is where they intersect. So the feasible region is the region between the two equations bounding by both of those.